if it's not up, there we go. All right, we're live here with second period. Say hi, second period. You can tell we're so excited to be here. So we're going to do, starting off at question 25 to 33. This is going to complete this. So basically, as a reminder, I went through the blueprint that the district provided about what AKS, what academic knowledge and skills are being tested tomorrow. These are my best guesses of what you could see for tomorrow's strategy SPG. So let's look at number 25. 25 says, what is the volume of the three-dimensional shape created by horizontally rotated square? So basically, first, what shape would we get if we rotate it? A cylinder, right? I'm recording, thank you. So the formula is pi r squared height. That gives us the cylinder. Now here's the other trick. It tells us that the square has a side length of 12. What am I going to use for my radius based on that picture? Yeah, I have to divide 12 by 2 to get my 6. What am I going to use for my height of the square? 12. And I notice that all of these answers are in decimal form. So I am going to use pi and type it in the calculator. So I've got 3.14 times 6 squared times 12. Let's see if we get something close. 3.14 times 6 squared times 12. I get, oh, I don't get that. What is, oh, you know what? I didn't hit, my one didn't go in. You got A times 36 times 12. Yep, thank you. A it is. Okay. Next, Bethany had a sphere made of modeling clay. The dimensions of the sphere are shown below. Notice that they were nice and they gave us the radius, but you won't always get the radius. Bethany used clay from the sphere to form a right circular cone. The cone has a base with a radius of 1 or 11 and a height of 11. How many cones this size can Bethany make? I would not suspect you would get one this challenging tomorrow, but you might get one like this on the DA. Remember, the SPG is going to have more DOK 1 level questions than the district assessment. Your district assessment for second period is Monday, May 20th. So first we have to figure out how much clay she had altogether. So we're going to take the volume, and we know the formula is 4/3 times pi times the radius cubed. So that's going to give us our first volume. So we've got 4/3 times pi. The radius is 11, and that's cubed. So I'm going to do that math out. Yep, 5,575. .3. Okay, and then it says how many cones can she make from the sphere? And notice how it says the radius is 11, the height is 11. So don't forget that the formula to find a cone is what? 1/3 pi r squared height. Now, I'm going to show you the sneaky way to do this. Basically, they're asking you, how does the formula for a cone relate to the formula for a sphere? If we know here, this was saying if I fill this in, I'm going to get 1/3 times pi times 11 squared times 11. And we know that this right here, change colors, Michelle. This right here, look at this is pi times 11 times 11. And this is pi times 11 times 11. I mean, they're the same, right? Those pieces are the same. Because, and then here, see how this is a third here and this is multiplied by a third here? So if I have 1 here and 4 here, what do I multiply 1 by to get 4? 4, and that's the answer. So that was like a quick way to do it, but the better way, the longer way is now that you have this answer, you're going to end up putting in, we're going to have to figure out what one of these equal. So we could do 1/3 times pi times 11 squared times 11. This is to get the volume of one cone. So the volume of one cone is 11 times 11 times 11 times 11 times pi equals divided by 3 equals one cone equals 1393.8. So then the last step would be just to divide. We're going to divide how much clay we have altogether by how much is in one cone. And that's the other way you can get this problem. I get 4.002. So obviously 4 is the answer. Okay, so you can either get it because you pay attention to the formulas, or you can get it, find the volume of the sphere, find the volume of one cone, and then divide. All right, number 27, find the volume of this cone. Again, we just did the formula, 1/3 pi r squared height. We know that this is 5, so we're going to do 1/3 times pi times 5 squared times our height of 21. These actually are pi symbols, so we're not going to multiply by 5. I'm sugar shoots. We're not going to multiply by pi. 5 times 5 times 21 equals, divided by 3 equals, I got 175 pi. Okay. Select two of the following that adequately define a line that is perpendicular to a given line. So here's a line, here it's perpendicular. A line B is perpendicular to a line A if and only if B comprises all the points equidistant from A1 and A2. What number are we doing? 28, but why isn't say, I would think they would want to say perpendicular bisector. Okay, the answer is, I mean, this is true assuming it's a perpendicular bisector. Okay, a line B is perpendicular if and only if. All right, the answers that they want you to know are A and C. I don't know if you're going to see something like that. Okay, 29. The basic concepts of line and point can be used to define a ray. A ray is a portion of a line that starts at a point and ends in a particular direction. How can this definition of a ray be used to formulate a definition of an angle? D. Yeah, it is D. An angle is a figure formed by two rays extending from a common point. That's good. Well done. 30. Which of the following is the most precise definition of a line segment based on the notions of point and line? What did you guys get? No. Okay, so let's look. A line segment is a figure comprised of 2 points and a line. Well, here's a line. Here's 2 points. That doesn't give me really anything. So it's not going to be A. A line segment is a portion of a line that lies between. That's true, but it wants the most precise one, so I'm not going to cross it off. I want to see if there's something more precise. A line segment is a portion of a line that connects two distinct points on the line without extending beyond them. That's probably going to be the answer, because it says it connects two portions of a line without extending beyond. So it's going to be choice C. 31, let P be the set of points XY in the coordinate plane such that 3x plus y equals -4. You won't have a question like this. Cross out 31. I missed that one. If you want to do it, the answer is a line segment. I mean, it makes sense because it's distinct, but you won't need that one. 32. Two rays extend from a common endpoint. What's all the things that can be formed? Well, if they share a common endpoint, we could have it like this, but then we also could have it like this, right? So it could be a line because it could be a straight angle that's 180 degrees. It can be an angle like this. It can't be parallel lines because they touch. It's at a common endpoint. It can't be a line segment because line segments go on forever. And it can't be perpendicular lines because, again, lines extend forever. So it's A and B for number 32. The set A contains all points on a plane that are distance D from a point. Oh, this has got to be a circle. Remember, the definition of a circle is the set of all points equidistant from the same point. So that gives us the circle, even though my circle looks really, not like a circle.